Did I solve this thing? We're gonna have to find out. Truth is that it got the best out of me. I thought it was gonna be a simple problem where I just go through rows and columns and validate some inputs. Well, it's LeetCode. We're gonna need a formula and we're also gonna need some tricks. So let's find out if I got this problem right. All right, welcome back to day 14 in our series of videos solving coding problems. In today's problem, we're going to be solving valid Sudoku. I made a video about 2 days ago where I was explaining that we found the roadmap here on neetcode, and we're trying to solve all these problems, right? And as I approach to harder or more difficult problems, I find that obviously I'm going to take more time to try to understand the problem and, dissect the problem a little more, see the things we're going to need before coming into these problems. So to solve invalid Sudoku, we need to know how to manipulate a 2D array, right? We need to know how to transpose a matrix. We need to know different ways to iterate through a 2D array or a list of lists, whatever you feel comfortable with. But the idea behind this is that you are capable to solve this problem by knowing that you're working with a list of lists or a 2D array, right? So we need that knowledge first. I did a little rant in the video from yesterday too, because I got frustrated a little bit for the fact of like try to solve these problems, but for most of these problems there's always like this little mathematical trick you have to know to solve the problem to have the efficiency level that you should. And I mean, I understand that and I really get that. At the end of the day, software development, it's science, it's computer science. So yeah, you're expecting things to be scientific, at least from the point of view of the things you have to implement, especially dealing with things like solving puzzles, which is the whole point of leetcode, right? So anyways, we know that by now, in order to solve valid Sudoku, we have to know a few things that I'm going to link in this video somewhere for you to go check it out. It's day 12 of the journey. And if you want to see me just talking about a few things I went through, go to day 13. And also, you're probably going to have some fun there too. But today's problem is valid Sudoku. It's a medium problem. We can see the companies here that asked this type of problem asked before, I would say, because some of these companies are not asking it anymore. But anyways, let's go ahead and read the problem. Let's go ahead and see what we got to do. So it says determine if a 9x9 Sudoku board is valid. Okay. Only the field cells need to be validated according to the following rules. Each row must contain the digits from 1 to 9 without repetition. Each column must contain the digits from 1 to 9 without repetition. Each of the 9 3x3 sub-boxes of the grid must contain the digits from 1 to 9 without repetition. It says, note, a Sudoku board partially filled could have valid, but it's not necessarily solvable. Could be valid, but it's not necessarily solvable. Only the field cells need to be validated according to the mentioned rules. Okay. So we got an example here. This is the visual example. This is how it's represented in a 2D array or list by list in Python's or list of list. And a second example here. Let's go and check the constraints. Always very important. So the length of the board, we know that it's going to be equal to 9. Every element inside the board is also going to be all the way up to 9. We're talking about the length, so from 1 to 9 or 0 to 8. And every element inside the column and rows or board I and J it's a digit from 1 to 9 or a dot. Okay, so columns, rows, combinations of columns and rows from 1 to 9 or a dot. The dot is going to represent the empty state or the empty boxes here inside the Sudoku. So a couple things, when we have 9 by 9 and also like when we have a lot of delimiters, these act as delimiters because we know we have to check things that are very in a very specific range. Okay, so the board's always going to be 9 by 9. It's always going to have rows and columns up to 9 or duplicates, and that's where where logic is going to come into play. And also we have to find a way to get into sub boxes. Okay, and I'm going to go ahead and pop into our whiteboard. I did a little bit of the homework already, so I make the video less painful. But basically, this is how we are going to traverse the whole Sudoku board by items and, rows and columns, right? So it's a list of lists. We know we're going to have a nested loop at some point where we're going to be going item by item. And I just said here, the cell is going to be where that row and column are at the moment. The best way for me to understand this was doing like this coordinates, getting this coordinates, which is basically what we're doing here. When we have a Sudoku board like this or a 2D array, what we're doing is as we iterate through these array is going by coordinates, right? Because each station of that pointer is going to be sitting on top of certain positions. So certain combinations of those positions are the numbers we are specifically looking for in our case, right? So if I want to find, let's say 6 right here, if I want to find this 6, so I know that my coordinates are going to be when my row section is on top of this one right here, which is the third row, and my column is going to be in its fourth position. So that intersection that happens there is the coordinates or are the coordinates of my 6 right here. And how do we determine rows and columns? Well, we know that again it's a list of lists, so every item that we iterate through our first iteration, it's going to represent rows, and we can see how it's in our case it's multiples of 3, since we have a 3 by 3 grid, a 9 by 9 whole board. So 0, 3, and 6, because we have 3 sections, right? We have, and I'm gonna point that out here, we have this section, and this section. So these are our sets of rows, okay? And also we have the same thing, but going vertically in our column sections, okay? So every time our row section changes, we, as we can see here, from 0 to 1 to 2 to 3. So if we go vertically in this direction, we are changing rows. If we go horizontally in this direction, we are changing columns, which seems pretty obvious, but little factors that we have to understand because we're going to need that later. So just know that these are the coordinates basically that represent our board. And I try to make it a little easier there, I and J, or rows and columns, and that's the way we iterate through the board. Now notice that I don't have here the dots in our board, just they're represented as empty spaces, but again, they still have coordinates. So these whole 3 sections right here are empty sections in our Sudoku board that we got as an input. Okay, so just to know that before we get into to solve the problem. So now we know how to manipulate this board. Now what's next? Well, it's asking for uniqueness, and we can have multiple ways to determine uniqueness. We know that we can use many different data structures to insert our numbers and determine if we have seen the numbers before, right? So I'm just gonna have these numbers right here. These are their index, and this is just a quick example, but let's just imagine this is an array, right? And I'm just gonna represent it like this, okay? So in this array, every time we want to check if there's if one of our elements is in this array, right, we just go ahead and do a lookup, right? We go ahead and say, hey, it's the cell we are on right now in our code right here. Is it in our data structure that we're using to keep track of the numbers we're seeing, right? Now, I mentioned an array, but when we think about what we need is where we think about our design in terms of data structure, right? So if, and this is the part where we have to study and know these things previously, if we look up which data structures are more efficient to test uniqueness, membership, and insertions, because at some point, remember that the data structure, it's going to probably start empty, and then we're going to be adding numbers to it, right? Because we're going to be traversing the whole grid, and every number we find that is not in it, we're going to add it. So at the end of the day, these numbers right here that are going to go from 1 to 9 have to be all different. And if the number we are traversing to, let me just go ahead and put a 5 here just for the sake of the example. If we're at this point of the list and we look up here at our data structure and we say, hey, it's this number right here that we get by our coordinates in our array, yes it is. Well, we know that immediately the data structure or the grid, it's going to be invalid, right? Okay, so when we look up at those conditions, then we are going to be thinking about a set, which in Python and in Python it's called a set, but it's basically, it could be a hash set, I think, in Java, or a hash, not a hash map. It's going to be a hash set in the case of uniqueness, because the cool trick about sets in Python or Java is that they don't when you're testing membership, they don't accept duplicates, right? So every number in our set is going to be unique, and I'm saying numbers in our case specifically, but sets, you can have any combinations of parameters. You can have strings and whatnot. Okay, so sets are very powerful. Actually, sets are very used in large language models because we use the alphabet as the combination, more characters, but just the 27 combinations of our letters to check uniqueness, and from there we do all kinds of algorithms, and I'm not gonna go down that rabbit hole, but anyway, sets are very powerful, and it item lookups, we're testing if the item is in the list already. If it's not in, then we go ahead and add it. Insertion. So we're talking about two quick operations we need to do: lookups and insertions, and sets are the best for that. So we have that. Now, we know how to traverse the list. We know that we're gonna be testing for uniqueness, because those are the rules that it's saying here without repetition, which means obviously they have to be unique. We know how to traverse each row and column, and we know how to test for uniqueness, or how to get uniqueness, right? What else do we need? Well, it's talking about a 3x3 sub box, okay? It's talking about that how we, besides iterating over every row and column, are going to test. We need to test for sections inside the board, okay? And that's where this is going to become more useful, right here. So basically what it's saying is, our board has, it's a 9x9 board as a whole, right? It's a 3x3 in sections, right? So if we go by this section right here, that's a 3x3, has 3 columns, 3 rows. If we go as a whole, it's a 9x9 because we have 3 rows and 3 columns. So what are we seeing here? We're seeing 9, we're seeing 3. That's supposed to be a 9, but I'm doing it with my mouse. I don't want to plug my my little pen. But we have a 9, we have a 3, so we know we're dealing with numbers that are multiples of 3, and that's where a little function or formula is going to come into play later, because we need to find a way to get into the sub boxes. We know how to navigate each independently row and column by our coordinates, but we need to know where those coordinates are sitting on in sections, okay? And I have them here in this square. I separately in this squares. We have this 3x3 here. We have these other 3x3 here on this side. Why not? Which are represented the same way here, right? So besides our conditions of testing that all the numbers in this section and in this section, rows and columns, have to be unique, we also have to make sure that in the little section right here, they're also unique. So how do we get there? Well, the way to get there is by combining the coordinates we get from our columns and rows, and we're going to take our rows and our columns and divide it by 3. That result of our rows, we're going to multiply by 3, and we're going to add all that together. How do we come up with that? Because that was one of my questions. When I was studying, obviously I didn't come up with this. This is some math wizard, probably the guy who wrote the problem or the girl who wrote the problem came up with this, or all the geniuses that we have in computer science, bless their heart. So I was like, how do you come up with that? Well, we know we have multiples of 3 because we are in a 9x9 board, and we also have a 3x3 mini sub boxes, which they pretty much gave us the hint here, right? So we need to find a way to label, if you will, these sections, right? We need to find a way to label them, because at the moment of exploring what's inside them, we need to have them in certain area where we can explore them, right? I hope that makes sense. I'm trying to explain it to myself too, like I'm 5. So why not? So anyways, we have to label these sections so we can say, inside those sections, do we have duplicates too? And a good way to do that is this formula here that takes the row we're on divided by 3, and that would basically say, let's go ahead and move our needles right here so we can take an example. Let's say let's do it with 6, okay? Let's do it with the 6 that's already marked in there, where this grid is going to be right here, and this is going to be right here. And the point where they are intercepting right now is actually it's a column up right here. And the point where they're intercepting right now, or intercepting, whatever the accent you prefer, this one right here, Okay, let me make these. There we go. Alrighty, that's a little better. So that's the point where they're intercepting right now, and that is going to be the coordinates we're going to take. Okay, we're looking for 6 here. Imagine that we are traversing the board with our nested loop, and at some point we land over here, and we want to find the sub box, the mini section that contains our 6. Well, we're going to use the formula. That's going to take our row, which is equal to 3. It's going to divide it by 3, and I'm going to do this in linearly on time right here. So that's going to be equal to 1, okay? So just go ahead and substitute this by a 3. That's going to be equal to 1. We're going to be using floor division because, remember, we want entire numbers. So we want integers. We don't want any floating points, so we're going to round everything down using floor division in Python. We'll do that later, but we use the double slash. But anyways, we know that this number being a 3, we divide that by 3 equals 1. We go ahead and just for the sake of following the operation, we're going to do parentheses first. So we have j equals 4. 4 divided by 3, it's equal to 1. Remember, we're using floor operations. That's like 1.6 or something, but we're not getting into that. So we're just going to go ahead and do 1. We have that result. So 1 times 3 is going to be equal to 3, right? We'll multiply these two right here. And then we add that together, that 3 plus 1, and that's going to be equal to 4, okay? So that is going to be our label. It's saying that our 6, based on the coordinates we just grabbed from here, it's going to be in the box or subsection number 4. And how do we know that? How do we get there? Well, we are going to use the same method we're using to traverse the list. It's index based, right? So what we're saying is this box is going to be index 0. This box is going to be in this 1, 2, 3, and specifically ours 4, okay? 5, 6, 7, 8, okay? We have 9 boxes starting from the 0 index. We have 8, okay? But again, we found the coordinate of our 6. We found the little section where 6 lives, right? And that is the 4th grid, right? So that is how we're going to label. That is how we're going to say to our code, hey, besides checking rows and columns that the numbers are non-repetitive, that are unique, go ahead and that little section based on this formula, check if our little section, okay, it's also unique. And that is how we're going to be doing that. So yeah, I think those are the main parts of our problem. We have to test these 3 conditions at the same time. They all have to be true at the same time for the board to be valid. If one of them fail, obviously the board's not valid because it found a repetitive number in one of our sections. So besides that, I think we are good to go. We're going to remember that dot is going to represent an empty state of the board. So let's go ahead and try our code. I think we're pretty much ready. I'm not saying my solution is going to be straightforward. I'm probably going to have to debug it too. So just let's do it together. Let's go ahead and jump in and see what happens. So we know we're going to need rows, columns, and a way to store our mini sections, okay? So what we're going to do, we're going to have rows, and we're going to use a set, okay? So the way to use a set, we want to store all the sets inside an array, so we can have 3 different sets that can take up to 9 numbers each set, right? It's from 1 to 9, so every time we see a new number, we add it to the set, okay? And once we have the set completed, in case the section we're exploring is complete, then we check for membership, or we check for uniqueness, okay? So rows are going to be equal to a set, and we're just going to type set. That's the way to create a set in Python. So we're going to say set for, we don't need to use any parameter here, in range of 9, okay? The reason we're doing this is because we know that our board is going to be 9 by 9, okay? And also we're going to be looking for numbers from 1 to 9. So we need 9 spots, okay? So we're hard coding this right here, but also this could be more dynamic depending the input. In our case, they're giving us hard coded values, so we are allowed to do that here. If you want to be like more a little more, I don't know, pragmatic, you can use length equal to 9, and that way you just input L here if you like that better. But we can go ahead and hard code that in there. It's not going to change anything. We're going to go ahead and do the same thing for the columns, because that's exactly what we need. And for the boxes, or subsections, whatever, we're pretty much going to do the same, because we're iterating over and over each section, okay? So we created a set for every number that we need. The next thing we're gonna need to do is check for, so how can we, we have the 3 data structures. How do we go ahead and start testing things? Well, we have to, again, going back here, we have to check, we have to check our every element, every row, every column, right? So that's what we're gonna do. And this is the only time I believe we're gonna need to go through the loop, because we're just checking everything once, and if it's not empty, then we'll apply our logic into it, okay? So I'm gonna say, and I'm gonna use R for rows to make it easier. So for rows in for rows in the board, I'm not sure if I have to use, yeah, of course. What am I thinking? I need to use range length of the board. For I inboard, for J inboard, do I need to use that? I'm not sure. See, for range in, I'm gonna say for rows inboard, for columns inboard. So these are our items. What do we need to do now? Well, we need to see if it's a number or if it's a dot, okay? Because if it's a number, we can operate on it and check, if it's in our set already, if it's, but if it's a dot, we don't need anything from it. So the way we're gonna do that is, if the item we're on right now, okay, which is the specific cell we're on based on this board, if the board at rows and the not toes but rows, and the board at columns, if that specific item is not equal to a dot, if it's not equal to a dot, then we're gonna operate in it. So what do we need? So we need to determine the number we're on. We need that number. We need to grab that number, because we're going to be adding that number to our data structures, okay? So we know now that we're past this point. We know it's not a dot, okay? So we know it's not empty. So what do we do now? Well, we want to grab that number, so I'm just going to go ahead and say num at board rows and columns, or that specific row and column. That's the number, okay? Because I'm gonna operate with that number later. And the next thing I'm going to need is, so I can test directly in my rows and columns right here because I have the number. But what I'm gonna need to test in the boxes is what we talked earlier. It's the label for my IDs. And the way to get the label is going to be using this formula that divides the rows by 3, multiplies and divides the columns by 3, and all that we're gonna add it together, okay? So what are we gonna do? Well, we're gonna say that this is our box. We're gonna say is our box ID or IDs, okay? And that's going to be equal to the formula we have. So it's gonna be, you know, our rows floor division in Python using double slash. We're gonna use the rows. We're gonna divide that by 3. We're gonna go ahead and multiply that by 3, and then we're gonna go ahead and take our columns and floor division that by 3. Now we know that every time we iterate through here, we're gonna grab our number, whatever number we're on right here, and we're also gonna grab the section we are on. So we have our number and our section, okay? So what do we do now, okay? So we have the number and we have the board section. We need to check if they are if they're unique. What would be the way to check if they're unique? Okay, so now we need to test for our conditions. Okay, basically that's what we need, and we need to the 3 conditions have to be true at the same time. Okay, so how do we do that? Well, we're gonna do an if statement here, and we can do this multiple ways, but a way that I found intuitive is to kind of Python feels like another language using this parenthesis here. But let's go ahead and add this if statements here. So I'm gonna say if the number I'm looking for it's in my rows. So if the number is in rows, if the number is in my rows, or okay, because we want to link them all together. It doesn't have to be. So what I'm thinking is to do n, but it doesn't have to be because it could be in rows, but not necessarily in columns. Okay, so the way to do that is or, because if it appears in rows or columns or in the box sections, it's automatically invalid. Okay, so it's going to be, num in rows. And I think since I have the number, I think I'm going to use this as my index. If num in rows, I don't know, feels a little wrong there, but let's see. Let's go ahead and move on with it. If the num is in rows, we can tab that and bring it in. If the num is in columns, and we're testing for membership here, or if the nums, the board add, okay, so num, let's see here, guys. Let's see where we at, because I'm going to need, the way to get that would be using the number as my ID. So if I say board, nope, I know what I'm doing. I have to check for that number as an index. So I'm gonna say if rows at index of what that number is in rows, right? If the number is at that index is in columns, and if boxes at the ID will determine, so at that section, if the number is in that section, let's see. I might have this backwards, but boxes at that ID, oops, box, how do I name this? IDs, boxes at box ID in, and boxes. So one of these conditions. So I'm saying if the rows is at, because this is the particular, this is the coordinate I'm on. So if the number is in rows, I need that particular number. So how would I get, no, because, okay, I'm gonna pretend that I'm going to explain this. You probably on the other side know what's happening, but what I'm saying here is backwards, because I'm saying if it is here in rows, well, rows is right now, it's at this point it's just a list of sets, right? So we're not going to, there's no way I'm gonna find it, you know, so it's gotta be, if the number we're on right now, it's in rows of nums. So I'm just gonna go ahead and copy this. Actually, it's gonna be easier just to do this and just say, you know, num, the number specifically I'm looking for. The same thing I'm gonna do here. In columns, so I'm gonna go ahead and say num. So if the number is there, and if the number is in boxes ID, okay. So I think this is going to be the way to find it, okay. I could be wrong, okay. So if the number is in the rows at that index, columns at that index, or boxes at the ID we are on right now, which the ID just means the coordinates of that little subbox we're determining with the rows and columns inside our loop, because we know that it's not empty, okay? So if it's not empty, and that's the case, then I believe here, so we check if it's not there, we can go ahead and return through, right? Or yeah, I believe we can go ahead and return through here, because if our conditions are real, I gotta close this right here actually. Let me see if it looks better like this, right? And then I'm going to say return true. Now, if that's not the case, you know, and if that's not the case, and it's not, so it's not a dot, but that's not the case, what do I need to do? Well, I need to go ahead and add the number now. So how do we do that? I'm gonna say rows dot add nums, rows at that num, right? Or rows at that column, rows at that number. I believe this is it. Columns and boxes. So I'm gonna say, you know, if we see if the number is in one of them, go ahead and add them. Okay, so boxes dot add that number, that particular number we have. I believe this is it. And if we go through all that, and if we go through all that, nothing happens, we can go ahead and return false. I believe this is it, but I'm not so sure. I'm not so sure about this section right here. Let's just go ahead and see if that works. We got a runtime error, so it says, you know, it's valid Sudoku, line 99, rows and columns. What am I doing here? Not equal dot. Am I iterating wrong over this thing right here? Probably. I'm probably iterating wrong over this. List. This is maybe integer slices, not list. Ah. Yes. I'm iterating over board as if board is I'm iterating over the items here, not the indices, and then I'm calling the indices here. Okay, so this is why you do this kind of stuff, because you have to practice for this thing, because that's such a basic mistake, and you won't make it in an interview if that happens to you. Just letting you know, because that doesn't seem right either. No. Now I'm having rows divided by 3. Oh, I'm not adding. Jesus Christ, I'm not adding that. I'm just, man. See, another mistake to fill an interview. Anyways, hey, I'm making it fun right now, but it's not. Okay, what do we got now, people? List indices must be integer slices. It's definitely my loop over here. That's what I'm doing wrong, because it's saying I'm out of index. Come on. Okay, so this is again the basic things we have to practice a lot, and it's good that this kind of things happen, because there's only one way to make it sit in your head. We're using hard coded values here to iterate. The range we're going to iterate is from 1 to 9, so we don't really need to iterate over the length of our board. The length of our board at that point, it's going to be out of index at some point, because we're grabbing for one section, we're grabbing 3, so the length is going to be 3 and the other one's going to be 3. So yeah, when I'm getting down here, I'm already out of range, so I need to iterate over the range of 9. Okay, and that is something to keep in mind. Okay, now I know that if the row we're in right now, or the column is not empty, we're gonna grab that number, because that's the number we want to test for uniqueness. We're going to separate our mini box, and then here we're gonna say it's not the number I'm testing at that number, but that number is not necessarily an index at that row. I think this is right, but this is not right, because what I need is rows at that specific rows and columns at that specific columns. Okay, so I'm saying if this number right here, okay, now I'm testing for uniqueness, is at that particular row we are on from our loop. Same thing for our columns. Okay, and then if the number is in our little section, we just determine right here based on our rows and columns. So if it's in there, well, if the number is in there, I'm actually not returning Flask, returning false, because if it is in there, guess what? It's not not true. Okay, so it's false. Then we go ahead and add the number here, and then here we can return through. Okay, so I had that a little backwards. And I believe here here I have a problem too, because I want to add the number not in rows. Okay, that's an error. I want to add it to that particular row. I want to add it to that particular column, and I want to add it to my particular box ID I just determined, or box IDs, right? And it's going to be added to one of them depending on where it's at. Okay, so if the loop goes past here, if we pass these 3 conditions, go ahead and add every number in each a specific position, okay? And it's row and it's column and in that little section. If we go through the whole section here and we add the numbers and we iterate over the whole grid, then and only then we're gonna return true. And I believe that is gonna be our code. Yes, perfection. Okay, so we haven't tested for all cases, but we can do a little celebration. What do we think about some confetti early on? Bam. Anyways, let's go ahead and submit that, because if we pass the 2 test cases, we can see if it works. If we're missing something, it's going to be towards nice. Ooh, love to see that. 98%. Look where we at right here. Beautiful. Now, I've seen other implementations of this, okay, where they do basically this backwards right here, where it basically says if this is equal to this, go ahead and continue, and it goes somewhere like this, continue, and then this whole section would be out of the loop, out of this if loop will be basically here, because we tested that now. But I think it's easier and more readable if we just say, hey, if the board at this point right here, if the board is not empty, if the specific grid we're on right now is not empty, then go ahead and do the operations. And also, I think like hard coding all this into, like, I guess you could do this. I could put that in here and it would be the same. And I could also do that in here. I think that's less readable than having that computated before. I think it's better if we just go ahead. We know we're gonna need that, so we go ahead and do that. And also we know that we're gonna need that number. So it's just gonna make things more readable. And yeah, perfect. I think we solved this problem. I hope you got something of value from this video. Thanks for sticking with me this long or getting to this point. Please subscribe to the channel, like the video if it was of your liking. Dislike if you didn't, it's okay too. I just really appreciate your time for being here. You're pushing me forward in this journey, and I really value that. If you subscribe to the channel, would also help me a lot to continue in my journey. And I hope catch you on the day 15. All right, thank you.